So we're excited to have Mr. Khalil Adib with us, who will walk us through the theoretical background and share valuable tips on building large language models. Khalil is a machine learning engineer specializing in AI, LLM, and generative AI. He works at Firemind, an AWS Premier Tier partner, and holds 6 AWS certification. Bravo, Khalil.
Thank you.
Including the ML specialty. He holds a master's degree in AI from London University, right?
City University of London.
City University of London, okay. And he has built AI-driven solution across industries, and he's still contributing to open source AI projects. So welcome, Khalil, and the floor is yours.
Yeah, thank you, Dr. Ihab, for having me. I will share my screen and one sec. Why this is not being good? Can you tell me, guys, which screen can you see? Can you see the PowerPoint presentation? Yeah.
Yeah.
Yes.
Cool. Yeah. Okay. Let's get started. Thanks, Dr. Ihab, for having me. I'm really excited to present to you guys today about building large language models. We won't go through a lot of details, obviously, because we don't have much time, but I will try to make it as conversational as possible. So I won't be just like talking about stuff. I'll try to make it conversational with you to just make everyone learn and interact, because it is the best way. Because if I sit here, I talk for the whole time, you won't learn as much. So first of all, just before we start, I will be speaking in English, and if you don't understand, just like some of the terminologies or something, you can ask me. It's okay. And because it is recorded, so I'm not sure if some of like people from outside Lebanon joined the session. So just to make sure everyone can understand, and because I want to upload it somewhere else after this. Just to repeat in Arabic, أول هحكي بالإنجليش. إذا عندك أي شيء بتقدر تسألني بالعربي، ما في مشكلة، أو فيك تحط بالشات. No problem at all. So yeah, today's outlines in today's webinar, we're gonna talk about building large language models. Even though I don't think no one will go and actually try to build large language models, right? Because these models are like really massive models, and it requires a lot of knowledge and energy and the money to build. They are really expensive, but at least you would have an understanding, not actually how the architecture work, which is the transformer, because it is all of our state-of-the-art sort of models are based on the transformers. But just to give you an idea how these models work, and then how these models they are being trained, and then what matters for these models. And as I said, this will have a lot of information, so I will try to make it as interactive as possible. And I won't be able to cover everything, but I will try to cover as much. So we're going to start with an introduction and overview. Obviously, Dr. Ihab introduced me. I will reintroduce me and overview about the sessions. We're going to talk about, just so I have a typo in here, but we're going to talk about pre-training and post-training in LLMs. What does pre-training means and what does post-training mean? And then under each one, we have tasks, loss. What is the task for that machine learning model? Because at the end of the day, it is a model that must do something, right? How we can follow the loss, how we can evaluate the output, what data can we use, and we're going to talk about scaling laws in LLMs, we have systems, but I didn't include it in this session because I don't think we have enough time to cover systems. And if we have time at the end, I will try to explain a bit more about it. And post-training, SFT and RLHF, which I'm pretty sure most of you guys heard at least about these terminologies, which I will explain. I choose this this title, building large language model, or this theoretical part, because maybe in the future we're gonna just do more stuff about LLM, and then I'm aware other people are presenting as well some stuff regarding fine tuning and using knowledge bases and stuff like that. But I think even like I said, you wouldn't go and build LLMs from scratch yourself, but it is really crucial to understand how these are being built in the industry. Before I continue, just want to get an idea of like, are you all guys masters students or undergrad, PhD? What is the percentage and what are you studying? Like, are you all a computer science student?
Actually, Khalil, we have a diversity of student. We have PhD holders also. So
Nice.
yes, graduate and undergraduate student. So
Nice.
there is no specific percentage,
Okay.
but you have to assume that we have a diversity of in the audience.
Okay. I will assume that most of you have heard about LLM before, right? And have some knowledge in math or something, right? I'll take this as a yes. Okay. Cool. Introductions. Obviously, like I said, Dr. Ihab introduced me. I will reintroduce myself. My name is Khalil Adib. I am AI ML engineer. 4 or 5 years ago, I was still in Lebanon doing computer and communication engineering at IUL, which is Islamic University of Lebanon. I did 5 years there. I was really interested in everything related to technologies, computers, software, even hardware part as well. Um, then by the end of 2020, I think, all of this stuff that happened in Lebanon, and then I took a decision that I want to leave Lebanon after I finish. Even though I did some I had some software engineering work in Lebanon, like as an experience in Beirut. But when I graduated, I like literally straight away went to London. I traveled to London and then I studied AI master's degree in City University of London, one of the best university in here. I graduated with a distinction, and then I was really interested in computer vision specifically. My thesis was about computer vision. And when I finished, I had the opportunity to I got introduced to the cloud, and I'm pretty sure like most of you, or if not all, knows what is cloud computing and what is specifically AWS, because I work for AWS Premier Tier Partner. Basically, we implement solutions for all of the customers for AWS, and like I go to actual Amazon offices like literally every week to present or to talk to customers or whatever. My day-to-day job is building AI ML data pipelines for customer. And recently, with all of the Gen AI hypes for the last 2-3 years, we are focusing on AWS. We are focusing on Gen AI solution on AWS to add values to the customers, and I'm really interested in just keep myself up to date with all of the new research works. Like every day we have something new, so it is really important to keep up to date, even though like when you graduate. So that's about me. We're gonna jump about like the main topic. So the question is like before we start is like what really matters when training LLMs? Like any other ML models, right? If you think about it, we have some specific things that we have to care about in order to build a successful machine learning model. And then as you can see on the screen, there are like main 5 points. Obviously, we have more, but these are all like other points can be under one of these points, right? We have the architecture, the actual architecture that we're gonna be using. And when I say architecture, like, I mean, I assume we are focusing on deep learning because this is the hype for the last decades or so. Because we have different type of architectures. We started with the normal neural networks, and then we have convolutional neural networks, and then we got RNN, LSTM, transformer, and we have tons of architectures. We have variety of them. We have to talk about the training algorithms, the algorithms that are being used behind the scene in order to train these models. And obviously we have data because LLMs, they are like I call them garbage in, garbage out, because well, if your data is good, the output from the LLM is really good as well. And evaluation, even if you build LLM and your loss function is really low, right? But if you don't have a way to evaluate the system, basically system is shit. Like you don't know what to do with it. You have to evaluate before like you deploy it to production. You have to make sure it is really important. And then finally the systems, and the system means how you're gonna use this model at the hardware level, how you're gonna how you want to optimize it for inference. You have to take a lot of decisions if it is like real-time endpoints or inference, auto scaling, a lot of this stuff. Now, obviously, in academia, they focus a lot on architecture and training algorithms. Because they just gonna come up with a new architecture that gonna destroy everything, and like like Transformer paper did in 2017 from Google, and the training algorithms. Okay. So before I carry on, like, can you guys give me some suggestion about or like can you nominate to me some of the architecture that are being used today in the large language models? Do you have any kind of idea? What are the type of architecture being used? Do you have kind of any knowledge about it? Yeah, go ahead,
Yes,
Sarah.
Sarah.
There is LLM transformer architecture and also the encoder one.
Right, you are kind of right, but you didn't مثل ما بقولوا بالعربي ما صفتيها بالضبط. I will take it a step further. So transformer, we have, if you take a look at the transformer architecture, we have encoder and decoder, right? This is by itself an architecture that is called sequence to sequence. We have models that uses only the encoder part, and then we have models that only uses the encoder part. We have other architecture like mixture of expert. Did you heard about this before? Like to be specific, Mistral AI uses a mixture of expert, and even DeepSeek. I'm sure you heard about DeepSeek as well. They use mixture of expert as backbone architecture. Obviously, they are like more like Jamba and Bamba, like they are kind of similar to Transformer. However, in this session, I won't be like talking about the architecture specifically, and then even for the training algorithms, because the training algorithm as well, like backpropagation and stuff, it has a lot of math, and I just wanna make it, like I said, as conversational as possible and try to explain new cool stuff. On the other hand, in the industry, they focus on data evaluation in systems because this is what matters, right? What data do you have? When you have high quality data, you'd get better models, right? Evaluation, it is really crucial to evaluate the systems before to deploy it in practice. And systems, as I said, how to make it cost efficient and how to optimize it basically. Okay, so pre-training versus post-training. I'm sure all of you about use LLMs or use ChatGPT like every day. I personally do. Like I have minimum 5 tabs that has ChatGPT opened in my computer. Where like ChatGPT helps me with coding stuff, with rewriting and paraphrasing or summarizing text, extracting information that I need, helping me with my research and stuff. But actually, before that, before we get ChatGPT, we had even LLMs. They are not something new. Like they're not something new in terms of they're not like for the last 2 years only. We had LLMs for last 5 or 6 years or so. With OpenAI started with GPT-2, and then they released GPT-3. But the breaking point was on ChatGPT, because ChatGPT gave us the kind of assistant-like experience. But before that, actually, we just have a language models that models specific distributions, specifically the internet, and that just try to predict the next token. So that's why I chose this topic, just to walk you through the phases, and then how we achieve what we are in now, how we achieve the ChatGPT or assistant experience, how companies go through these steps, and I want to show you how hard it is to actually train or build large language model. So we're gonna start from, I would say, like first the basics, right? Language modeling. As you can see on the screen, language modeling is like learning the probability distribution over a sequence of tokens. Does anyone know what does this mean? Do you know what is that language modeling is? Okay, so language modeling is, as I said. Okay, Sarah again, you know, go. We have Ronnie as well.
Yeah, it basically predicts the order of words. You could say.
Yes, but when you say order of words, as if you are saying that we have the words already, and then we are predicting which one comes first, which is not. It is predicting something similar, but it's not that directly. I think Ronnie, you raised your hand as well. You wanna go ahead?
Yes, of course. Language modeling, it's whenever you are training something related to, let's say, text or anything like that, you train tokens, right?
Yep.
These tokens, uh, let's say, vary depending on their position in the text related to where they are. So what the LLM do? So he doesn't create millions of probabilities. He just take the most important words and do whatever he was fine-tuned to do, for example.
Yeah, again, you're kind of right, but even before jumping to the LLM, if I just like, if you see this on the screen, language modeling is basically learning the probability of distribution given a previous context. So, and as you can see on my screen, the probability of the word or of the sequence of words is "I love my Lebanon" is 0.01 because it is kind of like correct, like people use it, right? Because when you train, like in this case, let's say we trained a model that learns the probability distribution of these sequences, and then you can see these sequence is correct. On the second line, you can see "I the love." Like it is really rare to see someone writing or saying "I the love." So there is when the models learn the probability distribution, they learn the semantic knowledge as well, and then you can see when there is something wrong and then when there is something correct. And then lastly, you can see the cheese ate the mouth, which is semantically wrong, right? It is like the cheese doesn't eat the mouse, or it is the contrary. The mouse eats the cheese. So you can see as well there is a low probability for this to happen. If I want to put it in another context, like as I said, we have types of LLMs, and specifically we in the industry, the most famous one is the autoregressive models, which means given a sequence of uh, given a sequence of tokens, we have to predict the next one based on these previous one. As you can see, we have like p of x to p of x of l. It's equal to p of x1 times p of x2 given x1 times p of x3 given x1 x2. So it's like in statistics, and I don't know if you guys like the statistics people here heard about the something called chain rule of probability. So autoregressive models, right? What these model, as you, Ronnie, were describing, right? We have input sequence of tokens, and I will explain what is tokenization and what is token in a bit, right? Let's say we have input sequence of tokens. In this case, hello, my name is Khalil, comma I, and what happens is when we feed it to the model, as I said, I won't go through the models in details in here because it's gonna be like 2-3 hours by itself. The output from the model is like actually a probability distribution over a specific set of vocabulary, and we sample from this vocabulary to choose the best the best answer basically. So the task in this case is predicting the next token. What are the steps? The first step is tokenization, actually, because LLM doesn't actually understand words. They only understand numbers. So we kind of have to figure out a way where we can convert these input tokens to a numerical representation in order for the LLM to be able to understand it. Second step is we feed forward this to the network. By the way, can you see my mouse, right?
Okay. Yes.
Okay. We convert this to specific values, specific IDs, where the LLM can understand these IDs, and the LLM will, as I said, do the predict the probability of next token, and if at inference time we sample from it and then we detokenize, which means we just we're using some temperature and top P parameters. We sample from this probability distribution, and we choose the best one, and then we detokenize it, which means we convert the ID of the token to the actual word representation that can the human understand. Now, this only happens at inference time, but however, at training time, we just tokenize, feed forward, predict the probability of the next token, and then compute the loss, and then we repeat it again. I'm just conscious of the time, so I was trying to explain more about this, but I will, if you have any question about this, you can ask me at the end. So as I said, the task is predicting the next token from a fixed set of vocabulary, which means, in other words, it is trying to classify the next token. As simple as that. And if you did any ML projects before, or if you heard about ML, there is like really for the classification task, there is a like really famous classification loss that is used almost everywhere, which is cross entropy loss. Now, as you can see on the screen again, assuming this is the output probability from the model, and then you have the target probability, which is in this case, like you have to choose maybe the yellow token to be the correct one to predict next. And using cross entropy loss, you want to actually force the model to increase the probability of that yellow token and decrease the probability of the other ones. This is the mathematical expression for it, the true probability distribution, one shot, and then your model probability distribution. We kind of try to minimize that loss in the training process, which means at the same time we are maximizing the text log likelihood, which means, in other words, we are force the model to predict the correct token all the time, if that makes sense. I'm gonna jump about to talk about tokenizations. As I said, LLMs doesn't understand any words; they only understand numbers. So we kind of have to come up with a solution where like we can force the LLM to understand the inputs. So like there are like a lot of debates about this, and then there are a lot of algorithms. So someone might say like, I can just for the tokenization, I can just like separate all of the input text based on the space, which is basically create a token for each word and try to train the LLM to do that. But however, this has a lot of drawbacks. Can you guys name me one of these drawbacks? I mean, it is obvious on this, like it is obvious on the screen, but can you elaborate on that? Do you have any idea?
Come on, guys.
There would be no relationships between the words.
Well, that's the LLM is trying to do, like building the LLM is trying to learn this relationship between words. But I mean, for the tokenization point of view, it's not effective to tokenize based on the space. One of the issues is, like I said, on the it is obvious on the screen, typos, right? Typos means let's say if you tokenize based on the space, so you would build a vocabulary of all of the fixed correct words. But what if someone instead of writing character or a token, the person makes a typo and then typed token with M, for instance. In this case, the LLM wouldn't understand this new word because it's not available in its vocabulary. So this is like people do typos every day, like and everywhere. So it's not effective. Another way is like it doesn't work for all of the languages. Because some languages, like I think the Thai language or something, it doesn't have a lot of spaces, which is like you can't just concatenate a lot of characters at the same characters in one phrase and say this is one token. So the LLM will really struggle to learn that relationship. Another one is like the LLM in this case would have to create a vocabulary of every single word in the dictionary, which is impossible. It's not impossible, but it is really hard. Imagine how many words do we have in Arabic? I think 12 million. How many words do we have in English? 600,000. Like you see, it is really exponential, so it's not good. Another one might come and say each character as a token, which means we would have H as a token, E as a token, L as a token, whatever. While it can be really good, it can be really, really, really good to tokenize this, tokenize the LLM as this, but it's going to be expensive to run. The reason why is the auto-ingressive models will try to predict the next token at a time. So if you have on the screen, you can see, hello, I am presenting at the Monday webinar. The LLM will take H and then try to predict E, and then try to predict L, and then try to predict L again, and O, and so far and so forth, which is not good. It's going to take a lot of time from inference and money point of view. And then another problem is the context length. I'm sure most of you are aware that LLM can understand a lot of text, but to a certain points. So, like for instance, they say Claude model, they can understand up to 200,000 tokens. Gemini models can understand up to 1 million tokens. So in this case, you would kind of take a lot of from the input tokens that will be passed to the models. Now, we kind of figured out a solution somewhere in between. There is an algorithm that is being used today. It's called byte pair encoding. I won't go through the details again, but it is kind of way to, instead of tokenize the whole word as a token, you can say that for each word, for each 100, for each word, you can have 2 or 3 tokens, if that makes sense. Rani, you have a question.
Are you talking about, let's say, coming? So when he takes coming, he just eliminate the ing, and he just say come. So in other terms, he deletes every single vocabulary. I came, it became come. Comes, it became come. He removed the vocabulary and just understand the meaning of the word. And then when predicting, he transformed the vocabulary based on his own language, on his own grammar knowledge that is already built.
So this is really interesting. The LLM doesn't eliminate, but for like the example that you gave is really cool, because coming, for instance, will be translated to, for instance, come. This is one token, and then ing is another token. And the reason why is ing can be used in millions of other words, like working, gaming, whatever, right? So this is a cool way where, like, using byte pair encoding, the LLM can just chunk these inputs and try to build this relationship. Now, future work, I would highly suggest to read this paper. It's called Byte Latent Transformer, where like Meta came up with a new approach to eliminate the transformer at all, and then used something called the latent space to try to actually understand the inputs. Dr. Rehab, you have a question?
Yes, I have two actually. Khalil, the first one is, so you know the old manner in order to represent or to tokenize the text using the standard corpuses, they used to use FST, the finite state transducer, something like that. So my question here is, what is so, because here we are not, we are just preparing the data and the tokenization, right?
Yes,
okay.
We are.
So what is the advantage of using the BPE over the FST? This is my first question, and the second one is the BPE is applicable for all languages, all type of languages? Because There will be a lot of possibilities also in order to generate tokens in this case.
I think your second question answers your first questions, and because we don't have to have like first like fixed set of tokenization as based like as this name suggests. It works at the byte level. So it turns out like it understands the byte representation for the characters and then try to build that relationships. It's actually there is a training progress to train this tokenization to at the byte level concatenate all of the pair of bytes that can be replicable in any anywhere else in the text. Second of all, it works for all of the languages. That's the main advantage. So yeah.
Okay, sorry for just another question, please, Khalil.
Yeah.
So because I have read that let's say the advantage of DeepSeek over ChatGPT is the representation of the character. In DeepSeek, they use a small amount of bits in order to represent characters. Does this have an influence here?
So I think what DeepSeek did is they have you are mixing two things in here. So like the tokenization, I'm talking about the representation of the input texts, while what DeepSeek did is, and obviously I can talk about this in future webinars, is like they used they for the actual numerical representation inside the neural networks, they use less precision, because in any number, because like at the end of the day, inside the architecture, it's all kind of doing multiplication, matrix multiplication, and instead of representing in nodes inside the LLM as we call it F32, which is float 30 point, and then we have 30 point bits after the decimals. They use something called BF16 and integer 8, which kind of I can explain more in detail, but it is not related to this.
It's not related. Okay.
Yeah.
Okay. Thanks.
Yeah, sure. And you can see on the left, on the right, an example of the input and how it is being tokenized. This is actually a GPT-4 tokenization. So if you just go to this website, you'll be able to see it. So evaluation, how actually they evaluate the outputs? They use something called Perplexity, which is one of the most known evaluation matrix that can be used in language modelings to be specific. And I'm just kind of walking a little bit fast in here. I'm aware of time again. Basically, Perplexity is the exponential of cross entropy. As I said before, cross entropy is the maximize the log likelihood to predict the next tokens. And then you can see this is on the screen. It is this is the cross entropy that is being used to train the LLM, and then you have the exponential to give you the value. The value of cross entropy can be between 1 and then the length of the vocabulary. And in other words, if you want to understand how it works, the Perplexity can give us an estimation of how the number of tokens that the model is hesitating between. In other words, let's say if the Perplexity is 5, it means that at every time the LLM is trying to predict, the LLM is hesitating between 5 tokens. If it's حتنقولها بالعامية بالعربي، ال LLM كل ما بده يعمل predict لتوكن جديدة بيكون محير بخمس 5 tokens for instance. So and then
هلا بالبيت.
if the Perplexity is 1, which means the LLM is always hesitating with 1 token, and then it's almost like you can say that there is something wrong. It is really rare to see that. And Perplexity over time, again, you can go to this website's Paper with Code. You can see you can see like some of the Perplexity for the LLMs, and then you can see how the Perplexity from 2016 till now, to 2017 till 2024, the Perplexity is actually decreasing with time, which means the models are being just getting better with time. Before I carry on, there is one obvious one obvious drawback of using probability as perplexity as one of the main indicator? Can anyone just on the fly try to catch it? What is the like main problem with using perplexity as the main evaluation score? Think about it, because as I said, the perplexity can be between 1 and then the length of the vocabulary being used. So if you have a vocabulary
introduction of new words, introduction of so maybe you're gonna have a length that is greater than the vocabulary, maybe, or if it's between 1 and length of vocabulary, then how is it calculated? Does it need more time to calculate if it's doing the calculation? Because sometimes the calculation which is done is not optimized. So these are the two problems when I think of that.
It's not necessarily the calculation, the time to calculate, not necessarily a problem, because it's like kind of numerical represent like 1 over x or 1 over y, where y is equal x times something. It's not about the problem with time to calculate it, but you actually mentioned one interesting problem is like it's not directly again related to perplexity, but like when you want to add in new languages, how do you wanna retrain your model, which kind of like by itself another major thing that we can talk about later. But you were right about the length of the vocabularies, because for instance, ChatGPT will use a tokenizer or like OpenAI will train their LLMs on a their own data set, and then let's say that data set has 10 trillion tokens. So their perplexity would be based on that number of vocabulary that they used. And then let's say another LLM, maybe Mistral, they trained their model on more languages, which means they have more tokens in their fixed length of vocabulary. So maybe the Mistral one, the range of perplexity for it is like between 1 and let's say 10K, and then the OpenAI one might be between 1 and 5. Oh, sorry, 1 and 5K. So there is like mismatch in the representation of the number of vocabulary being used. So and then on the other hand, it doesn't give us a like direct impact of how good the model is. So that's why they came up with something called NLP benchmarks. Then there are like a lot of benchmarks are available nowadays. One of them is called Helm, which has under it a lot of benchmarks as well, like MMLU, some coding benchmarks, where essentially what happens is they would be kind of in a question and answer pairs, and then for instance, for each question they would have multiple answers, and then the LLM has to choose the correct one. And these comes from different domains, for instance, biology, coding, astronomy, history, whatever. And then they when they train the LLMs, they go to these benchmarks, they evaluate these LLMs on that, so that they can see the LLM answered all of the biology question correctly, the LLM answered all of the coding question correctly, and stuff like that. Another one is like you can go to Hugging Face, and Hugging Face, if you don't know, it is a repository to that open source repository that you can have access to a lot of open source models from there. They created something called Hugging Face Open LLM dashboards, where like people can go and evaluate the output of LLM based on how they think. Now, some of the challenges to evaluate LLMs in using the benchmarks is, first of all, the inconsistency, because if you have a benchmark and then you have a lot of questions with multiple answers, if you run the evaluation using the same LLM over the same data set, you might get different results. The reason why is the probabilistic nature or non-deterministic nature of the LLMs, and the sensitivity of a lot of parameters such as temperature and top P and top K, and sensitivity over prompts. So sometimes, like if you allow the model, like this is a technique for prompting called chain of thoughts. Well, like if you give the model a room to think before the answer, the LLM will actually give a better results. Another problem is data contamination. Does anyone know what is data contamination? Do you have any idea? Yes, Hassan.
مش مغلط is we have noise or bias on the human part making the data not accurate.
No, this is like maybe kind of related to the training part, but data contamination is like, how can we know that the LLM provider didn't train their LLM on the test set? Which means, let's say if they want to prove that their model is really good at math, they can go and create a benchmark or training data that has a lot of math problem, specifically math problem, and then they say, all right, we trained an LLM on this data, and when they evaluate, they would get like really high score. And this is what we say data contamination. Basically, essentially, is like when we train the model on the training on the test set, and then even without us realizing, because essentially, and then I will talk about data set in the few slides, where like they just scroll the internet and then train on it. There are actually some ways to detect if they the LLM is being trained on the test set. Some of them is like if they have access to the perplexity, if the perplexity is really low, which means the LLM has been trained on it. And another one is like if they change the order of options and the LLM is still getting it correct, which means the LLM didn't train on that. But if the LLM, if you change the output of the options and the LLM start getting confused, which means the LLM is learning the position of each output, which means the LLM is being trained on these data. Another one is like called benchmark saturation. So benchmark saturation, which means the LLM are getting really good at these benchmarks, and that they are no longer a good representation of how good these LLMs are. Or how we can compare these LLMs, because nowadays the more models with the big sizes, they are getting a really high score on these benchmarks, so we need more benchmarks. And I don't know if you saw, like OpenAI recently released a new benchmarks that can be used for software engineering. Right, so talking about data, so it is actually really important as well, because as I said, garbage in, garbage out, which means we train the models on the data, and then if the good data is good, the model would be good. Basically, what they do is like they train over all the internet. I literally mean train over all the internet. There are some crawlers that crawl the internet every month. One of the most important one is called Common Crawler. You can see they have more than 250 billion pages. Like this is the massive number, and it is growing over time because every month they literally go over every page in Google, they scrape it, and then they save it in the data set. Now it is really challenging because this is like a random page from the data set, right? If you want to train an LLM on this, it's gonna be crap. It's gonna be really shit because it doesn't know like what the fuck is this like. You can see that we have some information here called training materials are that one of the best reading feature of 004. This is kind of data they want to extract. So there are some methods or like filters they have to apply before actually batch these data and then send it to the LLM. One of them, first one is like remove the HTML tag because they are all from the web, and then all of them would have an HTML tags. Second of all is removing PII. Does anyone know what is PII? Okay, PII is personal data. So personal data, you have to remove all of the I don't know, account numbers, addresses, all of this kind of personal data that can be posted online. You have to remove it. You don't want to train your LLM on that. You have to remove deduplication. Hassan, you have a question?
بس سؤال اسمه البي اي اي. عفوا هلا رجعوا الفيديو، بس وقف الفيديو شوي.
Yeah. Yes, PII.
لا معلش.
Yeah, PII is like I'm not sure what is the exact ما بعرف شو هي ال exact
Personal
terminology.
information.
Personal information, yes, شي بعد but yes, it's something like this. Personal identifiable information. You have to remove all of this.
Personally.
remove duplication because you can find a lot of the same information over multiple websites. So you kind of don't want to retrain on the same information. So you have to make sure to remove some of them. There are some techniques to do that. And one point I'm not mentioning it in here is like there are some blacklisted websites that you don't want to train your LLM on. One of the biggest example is like, for instance, if there is a startup in America that they want to collect information, they obviously don't want to train their own LLMs on websites from Iran or from Russia or whatever, right? So there are some blacklisted websites that if the information comes from that website, don't use it. There are some heuristic filtering, which means it's like rule-based filtering. Again, this comes under the website checking is under the heuristic filtering as well, where like they just like remove all of this websites that they don't want. Model-based filtering is it's another kind of step that they use where they train another models to specify the domain of that website. So for instance, if they have a page, they train a models that can predict what is the topic of that page, if it is sports, entertainment, coding, and stuff like that. And then they do upweights some domains. So it turns out that if you train your LLM more on coding challenges, the LLM would be better at the reasoning tasks. So like they use that if they have data set, they get the distribution of all of the topics, and then they create some kind of balanced data set that have more kind of math, history, and coding challenges, and less entertainment and other stuff. This is in the nutshell as well, like how they collect the data, and then I think they hire more people to collect and clean the data more than the actual people who are working on the training part. Hassan, yes.
Yeah, so I was wondering, do they train the models on the information whatsoever the language is, or do they translate if there is like if they scrap a page in French, for example, or in Arabic or any other language, do they have to translate it before to English and then pass it to the training, or do they train the model directly on the native language?
So obviously, like first of all, to answer your question, most of the I think 80 or 90% of the internet is on English. First of all, second of all, yes, they want to train on other languages, and the tokenizers that they use supports multiple languages. But at the same time, if they don't want specifically to train on a specific language, they can literally remove it. They don't translate. I'm not aware that they translate anything because they already saturated with the information in English, for instance, so they can get maybe in the model-based filtering as well. They can detect what is the language in that page or the dominant language in that page and take a decision there. And even some of the HTML tag can provide the language being used in that website. Ronnie?
So my question is basically like if they're gonna do Devon, for example, and if it's gonna go crazy. So Devon is more or less trained on everything that is coding, right?
Yes.
So they scrape the internet. Forget about him being able to control the PC and do the debugging and do all that. I'm only talking about the logic in coding itself. So it has been like intensified on coding, and then they removed almost everything else, right? They just put the baselines.
I don't, from my knowledge, I have to recheck on this. I don't think Devon trained their own LLMs, but they use another LLMs as a service from OpenAI or Mistral or whatever. But they actually build an agent, which can, again, it can be part of another webinar. They build an agent that being instructed specifically to deal with code, if that makes sense. So they didn't train their own LLM, if that makes sense.
Really?
I think so, yes.
The agent that controls things, and then they use something from another service.
Yeah, I mean, I'm actually at work now trying to build something similar to this, where like I'm building an agent that can control your screen to do something.
Yes.
So I'm not training LLM myself, but I'm using.
Yes, I know. You just use things like Selenium and these things to control the something like that, depending on the task.
Similar, but yes, Selenium is for the web. But what if you wanna make the LLM control your computer, for instance? It's kind of another discussion, but it is.
I'll be interested in that topic, by the way.
Okay.
Because it's asked.
Yeah, in the future, I can talk about agents. Don't worry. Serena?
Yes. How can we make sure we're not training our model on AI-generated web pages when we're doing web scraping?
Really good questions. Really good questions. First of all, why you don't want to train on synthetic data generation? Because this is one of the challenges that we are kind of getting saturated with the data. Basically, they are scraping the whole internet every day, and some of them are relying on synthetic data generation to actually put more data into the models by like creating a problem and then make the LLM solve it and validated using a human or LLM as a judge. Again, this is something we can talk about it later as well, and train the LLM on it. Why? If the company, like specifically, they said, "Oh, I don't want to train on synthetic data generation," right? I don't know if you heard about, like, for instance, Zero GPT or Detect GPT. There are some websites that you can actually go and paste LLM generated text, and then the website can tell you this is a 100% text generation. How this is being done is they using some mathematical calculations based on the tokens that you are passing. They can check the log likelihood of the tokens, and then if it is really high or really low, it depends on the actual metrics they're using, which means it is 100% LLM generated. So it's kind of sit on the model-based filtering.
Okay, thank you.
Yes, cool. It's a really good question. And then another way is like, because nowadays all of the models are multimodal, so they want to kind of balance between images, audio, and text as well. What you can see on the screen data sets, this is actually a really massive data set. It's called Fine Web. You can go on the internet and search for Fine Web, and then you can find it. It is massive data set. It has 15 trillion tokens in it from different languages and different domains. Just to give you an example on which I will talk about it in the next slide. It's called scaling law. Llama 2 family has been trained on 2 trillion token. Llama 3 has been trained on 15 trillion tokens. GPT-4 has been trained, as the Lakes said, 13 trillion tokens, which is a massive data set, right? So scaling law, and then I'm aware of time, but I'm gonna speed up a bit. Scaling laws. So basically, there are like some research and some empirical data so far that says, so far, if we put more data to the LLMs and then train bigger model, we're gonna get better models. So like the term of overfitting in LLMs, it doesn't exist so far. So the LLM doesn't. We still kind of didn't hit the plateau where, like, we say, right, even if you put more data and more parameters, the model won't get better. So that's why every year or so you can kind of see a new big models. Like, I remember when GPT-2 is like a few million tokens as parameters, I think. Then GPT came in, GPT 3.5, Claude 2, Claude 3, and all of this kind of models. Llama has they started with 8 billion, 160 billion, and then 70, and then 90, and then 400 something billion parameters. DeepSeek has 671 billion parameters. So we're still in the more data, more tokens, more parameters, you'll get better models. And the question is, like, here in the scaling law, can we predict the performance of the models based on the number of parameters and how many tokens we are using? This is some active area of research, and then there are some paper which I will explain in the next slide. I think Hassan, you raised your hand. You want to ask a question?
لا صراحة كنت بدي أسأل عن هذه الورقة اللي هلا بدك تحكي عنها، فرجعت وطيت إيدي، عفوا.
Yeah. It's called Chanchella, which is, this is, if you can click on this link, you can get you can go to the paper. It is called Chanchella paper. Basically, what happens is, like, usually when the company wants to train an LLM, they start with the budget. So they would say, right, I have 10 million to spend on training the LLM. In the old days, what they would do is like, let's say if they have 10 million, 30 days to train an LLM. What they do is like, they go and for 30 days, they train one simple model. I'm talking about before LLMs, right? They train for each day one model, and then at the end, they try to compare all of the model based on the accuracy or validation loss that they are using, and then they choose the best one. In LLM, they can't do that. It's like there is no joke. They have to, if they have 10 million, they have to they have to use them carefully, otherwise they won't get the result that they want. So in this paper they did a study, and then they came up with an empirical data for a fixed flop. Flop stands for floating points operation, which means the like in the inside the LLM they essentially are doing multiplication and subtraction and all of this stuff. Each one of this is called flop. For a fixed budget, they would have a fixed flop. So they did like an experimentation over like if you have X amount of trillion of tokens, and then they compared the number of if they use 1 billion parameter model, 3 billion, 6 billion, 30 billions, and then they draw the loss. Then apparently there is a trade-off between the number of parameters and the number of tokens for a fixed budget, which means if you have a lot of data, you can't just go and train it on massive model, because it won't learn much. It will learn exactly the data, so the loss would be really bad. But however, like for instance, they came up with the conclusion of the optimal ratio for training is 20 token per parameters. So for every 20 tokens, you have to consider one parameter in the model, if that makes sense. So you can see on the middle, like the number of tokens. For instance, they had like, I think this one is for Meta or something. I'm not sure. For fixed flop, they came up with a conclusion that the optimal number of parameters is 63 billions, and then they had to use 1.4 trillion tokens in the datasets. Again, I can go a lot like more far in this, but I'm gonna keep it in here, and then you can ask me a question about it later if you want. So just kind of move again to the post-training, and then why we have something called post-training. So pre-training models is not it's not an AI assistance. So this actually a prompt and computation from the GPT-3, which is the model is being used as base for ChatGPT. You can see they send a prompt that says explain the moon landing to a 6 years old in a few sentences, but the LLM didn't respond in the way that the person or the people they want. It's kind of repeating the same patterns, which is that's how the pre-trained LLM is like being trained on all over the internet to learn the distribution of the tokens. That's it. They're not being trained to be an assistant. That's why they wanted to come with a way that makes these pre-trained model useful for humans. Otherwise, it wouldn't be useful. So post-training is the main goal of post-training is to align the LLMs with the human preferences to return the output that we want as a human, and refuse to talk about some stuff that we don't want the LLM to talk about. Like for instance, if you go to ChatGPT now and then say, show me how I can make a bomb or something, the LLM will refuse to answer this question. And then the reason why is in their post-training data, they force the LLM to avoid talking about this stuff. They did this is like, first of all, they fine-tune the pre-trained LLMs on something called SFT, which is supervised training data. This data can be like much less than the original training data that the LLM is being trained on. Like it can be 1% or 5% at most from the original pre-training data. One difference is like the data that is being used in here is high quality data, which means the humans are actually evaluating this data, while on the other hand, there is no any human intervention in the data side checking from, obviously they do filtering, but they don't, like there is no person is going to go and check each line of data sets, right? So they do that. They construct prompt and completion couple of pairs, and then they train on LLM. So given that context, you have to respond in that way, if that makes sense. So the task is the same, predict the next token. The loss is the same, cross entropy. Evaluation is the same. They use the perplexity, but they just, as I said, they use high quality data to um, to make the LLM respond in a way that we are as a human prefer. Does anyone know what is the most like challenges that the human can face in this and this to construct such data sets? Yes, Ronnie again.
Okay, it's more or less the variety of the variety of the subjects, and also it's more or less you can trick the LLM in a way to give it to you, like you can do overturn, so we can check so we can check the LLM, and this subject that's being talked about, that for example you ask it to give it something that is forbidden, but if it doesn't give you that something forbidden, like you can trick it in a way, and that's why it we say it doesn't like it's not perfect yet, right? So you need to find the sweet spot where like you cover all the subjects, okay, but yet you don't like allow them to like to be can we say the word political? So
Yeah.
just choosing the things that you don't want to show, but maybe they are not bad, right?
Yeah, so I think it's a great point you mentioned about like the coverage of the data. So obviously they have one of the problem is they have to create a data set that is like a balanced across multiple domains. This is one. Two, it is really slow and expensive to construct such data sets because, like I said, humans have to review this. Second of all, it like these humans must have like maybe like they say, for instance, for the SFT for OpenAI, they said minimum you have to have like bachelor's degree to construct this data set, which is really expensive. So you have to pay these people money to actually construct these data sets. Um, after that, they came up with specifically OpenAI. This was the breaking point of in LM's words, where like OpenAI they used RLHF, which is reinforcement learning from human feedback. Essentially, in the nutshell, again, there are two steps to train models such as ChatGPT. So first of all, there is the pre-training level or the pre-training phase where like I was discussing how they collect data and do filterings and do the training of the architecture on using the cross-entropy loss to predict the next token and stuff. They came up with a pre-trained model that is not being used as an assistance. Step 2 and 3, what they do is like they train a model different from the original LLM. It's called the reward model. The main goal or the main objective of that model is given two answers or given three answers, choose the best one. And then this is as well needs human labelers to say they given like they come up with multiple prompts. For each prompt, they have multiple options, and then the humans have to rate these. The human have to rate these outputs, and then they train a reward model to for a given input and outputs rank the outputs, and then they used that reward model in reinforcement learning to and then they use a algorithm called PPO, which stands for parity proximity optimization, which is originally like OpenAI discovered that algorithm. So for a given prompt, the LLM will generate two response, and the reward model will give a reward for each answer. And let's say if one has 5 out of 5 and then one has a 0 out of 5, so the LLM will learn to push its a policy to always generate the one with high reward. This is in a nutshell. This was the breaking points in the LLM words, where like we had now AI assistants that can that can actually give us the response in the way that we want and follow the instruction that we want in the format that we want. Now, after BPO, Stanford, I think, came up with another model called another algorithm called DPO. Stands for Direct Preference Optimization. As you can see on the left, you have the RLHF, where we have the preference data, labeled data from human. We have a reward model that will give a reward for each answer. And then we have the LLM policy, and given a rewards, it will optimize the policy. Again, this is standard reinforcement learning. You have a policy, and then you have a reward. So given a policy, given a rewards, you optimize your policy. For instance, if you have a dog, right, and you wanna force the dog to follow your instruction, so every time the dog behaves well, you give the dog a food. If the dog behaves bad, you don't give him anything. So which means the dog is learning based on that reward function that you are working with the dog to learn always to behave well. It's kind of the same. So in DPO, they said, you know what, I don't need RL in here. I can actually given directly use the maximize of log likelihood using cross entropy directly on the LLM outputs without reward interaction, which kind of trick in here is like kind of way to optimize. So they don't have now actually to train a different reward models different than the one they have already. This is the nutshell again, and using this way, they would be able to move from pre-training to post-training. Finally, in DeepSeek, and then I can talk about DeepSeek a lot in the future. The DeepSeek, what they did is they followed the approach of RL at scale, which means they started with their base model, which is in this case the pre-trained base model called DeepSeek V3, and they came up with a new model called DeepSeek R1. What they did is for each prompt, they sampled multiple outputs, and then given a reward function, which I will talk about in the next slide, they optimized the policy from an old to a new policy given the reward function. In the case of DeepSeek, the reward function was constructed in two ways. They forced, first of all, the LLM to have accurate response. If they have a math problem, they forced the LLM to output the correct math answer, first of all, or even if it is a code, they would actually execute that code and then see if it will work, and if they get the result that they want, so that they can give a reward, which means plus 10 points or plus 20, whatever the mechanism they were using. The other reward they were using is the format. So if the LLM is trying to solve a math problem, the format of the math equations should be correct. Or if the LLM is trying to solve a coding problem, the code should be executed by copying and pasted directly without modifying anything. In this way, they build their reward function, and then they optimized their policy to generate chain of thoughts at scale using pure RL. This is in the nutshell as well. So I think that's it. I'm aware, sorry, Dr. Ihab, we went a bit out of time, but I know there are a lot of information in here. For each slide, I can speak for 1 hour by itself, but hopefully this give you a general idea on the life cycle of building large language models and how hard it is. And maybe in the future, I can talk about the fine-tuning of large language models, how you can actually go and deploy it, and then how you choose the best hardware as well and stuff. And then I'm happy to stay to answer any of your questions, and if you have any. And these are my LinkedIn and portfolio if you want to stay in touch as well. I'm happy to. So yeah.
Thanks, Khalil, for the amazing presentation. Do you have any question? Anybody has a question?
I'm more than happy. Just take the chance to ask me any question, guys. I'm happy to answer. Hassan, yes, you have a question.
عندي سؤال شوي غريب. إذا في ديب سيك كلفتهم تقريبا إذا ديب سيك كلفتهم 5.6 مليون لحكي لي يعملوا تريننج للموديل اللي عندهم، والموديل اللي عندهم اوبن سورس، ما فيهاش شركة أكبر مثل OpenAI تعمل تريننج لنفس الموديل بس أحسن يعني بنفس الكود.
أولا, first of all, DeepSeek, they said it costs them 5.6 or 5.6 or 6 millions to train their DeepSeek R1 model, but this is to train the post-training model, to train DeepSeek R1, but the original training for the DeepSeek V3 is different because they started from the base
Yes.
model. They started from the base model and they trained the post-training model on that. Second of all, you're asking about ChatGPT and OpenAI. OpenAI, they had their own model first. So like actually DeepSeek is trying to do something similar to OpenAI, not the opposite. So OpenAI, they had something called Deep Research, which it's like a paid subscription. You have to pay $200 in order to use it. DeepSeek replicate this, and then they made it open source. And they share the paper, and then anyone can actually, if you have resources and data, you can actually go and do the same as they did, and you can get a model as well, like DeepSeek. Wissam, you have a question as well.
بداية يعطيك العافية كثير دكتور خليل على المحاضرة القيمة. سؤالي هون انه حكيت عن البربلكسيتي كايفالويشن الام اللي معنا.
Yes.
بدنا نعمل له كريات. كان سمول بيكون افضل. اول جزء من السؤال، كل ما كان سمول بيكون افضل. الفاليو للبربلكسيتي.
Perplexity, yes. As I said, if I go to the perplexity slide, perplexity is how hesitant the model is between certain number of words. So it's always between 1 and the length of the vocabulary, and then كل ما كان أصغر كل ما أحسن. Yes.
بس عفوا دكتور، ما في خوف انه اذا كان صغير كتير في مثلا نوع من الاوفر فيتنج للموديل، عشان هيك عم بيعطي مثلا سمول بيربلكسيتي؟ ممكن يكون هذا السبب.
So as I said, there is no such thing as overfitting in LLMs so far. So far, if you have more data and more parameters, the LLM will be better. And yeah, to answer the question, if you see a model with 1 as a perplexity, you have to think there is something wrong. It's impossible. Or the LLM actually learned the exact distribution of the data. So yes. So if you see in here, I think ChatGPT 2 fine-tuned, it has a perplexity of 25 or something. So if you can see like perplexity of 3, 5, 10, it's good. Hussein?
Okay, thank you.
Okay, thank you so much for this interested presentation. My question is, DeepSeek only use reinforcement learning for fine-tuning?
It's a good question again. 2 weeks ago, I did a presentation about DeepSeek as well. So DeepSeek, they had 2 models actually. So they started from the DeepSeek V3 model, which is their base model. They start with a model called DeepSeek R10. They used the pure RL to train their post-training model, but however, they got some problems. One of them is inconsistency in the output, which means in the format of the output, which means the LLM wasn't returning the correct output format always. And the second thing is the LLM was like trying to mix languages. So like if you ask in English, the LLM was like trying to answer in English and in Chinese at the same time. So what they did is like they used SFT, which is supervised fine-tuning. They used SFT first as they called it cold start fine-tuning. They fine-tuned their post-training model, their base model on high quality supervised fine-tuned data, and then they used RL. And then they called that model DeepSeek R1.
Okay. How it does handle cases where the reward function may not capture all aspects of a good response?
Well, in their case, because they were forcing, because they didn't mention the data that they used in the supervised fine-tuning, but I assume they focused a lot of math and coding problem. The reward function in their case, It had where is the reward function? Yes, they started with the accuracy. So like if they are solving a math problem, the math problem output is fixed. So they force the LLM to actually get the correct output. So if there is like I don't know, linear algebra equation, the output is at the end is a number or something. So they had to get this right. The second one is the format. So like when the LLM is solving the problem, they force the LLM to use the correct math equations in place. And after DeepSeek R1.0, they put a new reward terminologies for the consistency, which means if the user asks in English, you have to always answer in English. So they give a reward for that as well. And then if the user asks in Chinese, the user, the LLM has to answer in Chinese. And they used another rewards for to be the helpfulness and harmfulness and stuff, just to make sure the LLM is not returning toxic outputs. But yeah, if like I can send the paper later, you can, and then I can point you to the section where they mentioned that. So
thank you so much.
Welcome. I can actually go and show you now. DeepSeek R1. Oops. Oh, it's in here. So this is a DeepSeek paper, yeah. Training samples, blah blah. Okay, self-correction, templates that they used in reinforcement learning. Where is reasoning data and reasoning reinforcement learning? Where is the section that they mentioned the yeah, this is the reward model, accuracy and format. And they use these templates to construct their prompts. I can send this to the chat, and then you can have a look as well. Oops, I don't know why I can't send to the chat. I don't know why. I can send it later anyway.
Okay, no problem. Thank you so much.
Welcome. Any other question? Ask me. I'm here. Have the opportunity.
Khalil, do you prefer to stop the recording till here
Yes.
and we continue the discussion?
Yes. It's all right.
Okay.